Please open in your learning workbook to page 114. We will now complete two problems involving rationalizing a denominator with the denominator containing two terms. All right, here's our first problem. Root a minus 5, all divided by 2 root a minus root b. Now, you want to take note that down here in the denominator, there are two terms, 2 root a and subtract root b. This is different than the previous learning objective, so the method that we use must be different. Here's what we're going to do. First, make an exact copy of the problem as stated. Second, identify the conjugate of the denominator. The conjugate of 2 root a minus root b would be 2 root a plus root b. All right, what do we do with the conjugate? Well, we identify the conjugate and then we multiply top and bottom by that conjugate. All right, next, multiply the two fractions. So this is going to be a root a minus 5 times a 2 root a plus root b divided by 2 root a minus root b times 2 root a plus root b. Now, what we're about to do is a little bit on the challenging side. We're going to FOIL twice, once for the numerator and once for the denominator. All right, let's start with the numerator. So, FOIL. We want the first times the first. So that's a root a times a 2 root a. All right, now the outside. A root a times a root b. And because they're both positive, we'll write plus. So plus a root a times a root b. All right, now the inside. I've got a 5 times a root a. One negative, one positive, so I'll write subtract. Subtract 5 times 2 root a. And then the L part of FOIL, I've got a 5 times a root b, one negative, one positive, so I'll write subtract. 5 root b. Okay, now we're going to repeat that process down here in the denominator. All right, so 2 root a times 2 root a. They're both positive. Next, 2 root a times a root b. They're both positive, so I'll write plus 2 root a times root b. Next, the I part of FOIL. I've got a negative times a positive, which makes a negative, and a root b times a 2 root a. And then finally, the L part of FOIL. I've got a negative times a positive, which is a negative, and I've got a root b times another root b. All right, here's what I want you to pay attention to at this particular line of algebra. This is the step where students typically make their mistake if they are going to make a mistake. So here's what I want you to focus on. When you FOIL a problem like this, you're going to have a product, which is two things that are being multiplied, then an add or subtract sign, then another product, then an add or subtract sign, another product, an add or subtract sign, and another product. Take the time to think about your problem and make sure it is written correctly. You should have product, sign, product, sign, product, sign, product. This is going to be true down in your denominator as well. A product, a product, a product, and a product. And between each one, you have adding or subtracting signs. Okay, now we're going to start to simplify one product at a time. Let's start with the first product in the numerator. I've got a root a, a 2, and a root a. All three of those things are being multiplied. Multiplication is commutative. It can be done in any order. So I can put the root A and the root A together and the 2 out front. Two radicals with the same index can be combined with the product rule for radicals. So this is going to be written as follows. This is going to be 2 times the square root of A times A. Then I have my sign. Okay, next product. These are two radicals of the same type, so I combine them using the product rule for radicals, and I get root AB. Then my sign. Then things that are on the outside can get multiplied, so that'd be 10 root A. And then finally, there's nothing here that I can simplify, so I simply keep it the same, 5 root B, divided by. Okay, now we're going to do the same thing in the denominator. I've got 4 things that are all being multiplied. Multiplication is commutative. I can do it in any order. So I'm going to put the 2's together to make a 4, and I'm going to put the radicals together with the product rule for radicals to make square root of A times A. Then the plus sign. The outside, which is the 2, and then combine the radicals with the product rule for radicals, you get radical AB, minus the outside, which is the 2, combine the 2 radicals, you get radical AB. Notice I put it in alphabetical order, minus, combine the 2 radicals using the product rule for radicals. Okay. All right, we're now going to go up here and continue simplifying. Okay, so look at all of our radicals. They're now ready to be simplified. They're all square roots, so we're looking for perfect groups of 2. So there's a perfect group of 2, and another, and another. We've got 3 perfect groups of 2. Each group sends one representative out to multiply. So this right here is just going to be a 2 times an A, 2A. This, no change, no change, no change. So plus root AB minus 10 root A minus 5 root B divided by, okay, 1A is sent out to multiply, so we get 4A plus 2 root AB minus 2 root AB. Those are going to cancel. And then I have minus, and 1b gets represented, sent out to multiply. There's no more radical here. When you have perfect groups, there's no more radical. So this, no more radical, this, no more radical, and these cancels, so there's no more radical in the denominator. Now, is this our final answer? The answer is yes, we're done. You may be tempted to try to cancel this A with this A, or to reduce this fraction 2 over 4 to become 1/2. But remember, you can only cancel factors. Factors can have pluses or minuses within them, but not next to them. This A is next to a plus sign, so it's not a factor and can't be canceled. This A is next to a minus sign, so it's not a factor and can't be canceled. This is our final answer for this problem. Let's try another one. Three root 5 plus root 10 over 6 root 5 minus root 10. Okay, the first thing we want to do here is we want to count the number of terms in the denominator. There are 2. 1, 2. 6 root 5 is the first term, and subtract root 10 is the second term. Okay, what's the method we use when there's 2 terms? First, make an exact copy. Second, determine the conjugate of the denominator. The conjugate of 6 root 5 minus root 10 would be 6 root 5 plus root 10. Multiply top and bottom by the conjugate. Next, combine the two fractions into just one fraction. So 3 root 5 plus root 10 times 6 root 5 plus root 10 over 6 root 5 minus root 10 times 6 root 5 plus root 10. Now we're going to FOIL in the numerator and FOIL in the denominator. All right, here we go. Let's do our FOIL. Our first product is 3 root 5 times 6 root 5. Our second product is 3 root 5 times root 10. And because this is positive and this is positive, we write plus as the sign that goes in between. Our third product is root 10 times 6 root 5. And because these are both positive, we write plus. Our fourth product is root 10 times root 10. And because they're both positive, we write plus. All right, now we do the bottom. Our first product is 6 root 5 times 6 root 5. That was the F part of FOIL. Now we do the outsides. 6 root 5 times root 10. And because this and this are both positive, we write plus. Now we do the inside. Root 10 times 6 root 5. We have a negative times a positive, so we subtract. And our final product is root 10 times root 10. A negative times a positive is a negative, so we subtract. Okay, now we start to combine our products together. So I would like to really emphasize the idea here that there are 8 products, and in between each one is an addition or a subtraction sign. Make sure your work has that format. Otherwise, you've made a mistake. Inside the products, it should say times, 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 times. Outside of the product, it should say add or subtract. Okay, now we start to combine. The outside stuff can be combined, so 3 times 6 is 18, and the radicals can be combined to make a square root of 5 times 5, plus 3 square root of 5 times 10, plus 6 square root of 10 times 5, plus square root of 10 times 10, over outside stuff. 6 times 6 is 36, square root of 5 times 5, plus 6 square root of 5 times 10, minus 6 is the outside stuff, square root of 10 times 5, minus square root of 10 times 10. Okay. Now we're going to go back to the top here. So we have 18 square root of 5 times 5 plus 3 square root of. 10 can be rewritten as 5 times 2. So this is 5 times 2. That's the 10 right there. Plus 6 square root of, I'm going to do the same thing here. This 10 is going to be written as 2 times 5. That's the 10. Plus square root of 10 times 10. Over. Down here I have 36 square root of 5 times 5 plus 6 square root of 5 times, and 10 is 5 times 2. Here I've got 6 times, and this 10 can be written as 2 times 5. So I get 10 times 5 written as 2 times 5 times 5. Minus square root of 10 times 10. Okay, let's simplify each one of our radicals by looking for pairs. There's a pair, 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 and there's a pair. Each pair sends one representative out to multiply. So this is going to be an 18 times a 5 plus 3 times a 5 times the square root of 2. This 2 doesn't have a matching factor, so it has to stay under the radical. Plus a 6 times a 5 times the square root of 2. Plus 10. Notice that we have perfect pairs here, so no longer a radical symbol. Over 36 times a 5 plus 6 times a 5 times the square root of 2 plus 6 times a 5 times the square root of 2. This one should have been subtract. Sorry about the error there. This right here, when it got translated to here, this sign was wrong, should have been subtract. So this is subtract. Okay, so 6 times 5 times the square root of 2 minus 10 comes out, no longer need a radical, so minus 10. All right, 18 times 5 is 90. 3 times 5 is 15, so I get 15 root 2. 6 times 5 is 30, so I get 30 root 2. 36 times 5 is 180, plus 30 root 2, minus 30 root 2, minus 10. Notice that these are going to cancel. Plus 30 root 2, minus 30 root 2. Okay, back to the top we go. Now combine things that can be combined. Things that have no radical can be combined, and things that have like radicals can be combined. 90 plus 10 is 100. 15 root 2 plus 30 root 2 makes 45 root 2. Notice that the radical does not change. It's still a root 2. And then this is divided by 180 minus 10, which is 170. Okay, we're almost at the end. We have to simplify our result. Okay, we're going to learn something right now called Ryan's triangle. When you have a radical expression of the form number plus or minus number times a square root over a number, those three numbers form something called Ryan's triangle. So I'm going to make a triangle out of these three numbers. If you can find a common factor that divides into all three of those numbers evenly, then you can take that factor out of all three numbers to simplify your radical. So, what's a number that goes into 100, 45, and 170? The answer is 5. Remember, anytime something ends in 5 or 0, it's divisible by 5. This ends in 5, these end in 0. So I can take a 5 out of each one of these numbers. So divide by 5, divide by 5, divide by 5, and write the result. 100 divided by 5 is 20. 45 divided by 5 is 9. And 170 divided by 5 is 34. My final answer to this rather long problem is 20 plus 9 root 2, all divided by 34. Notice that the denominator has been rationalized. It no longer contains a radical. That's the goal of this problem. Get rid of the radical in the denominator.